This Indian tribe tour demonstrates that ASCII characters, when stored in memory in car arrays in C, are stored sequentially without regard to Endianness. For more information on Endianness and ASCII, take a look at the previous videos I made. Also, you can find all commands and source code on my website in case you want to copy and paste. Links in the description. I'm running a fresh Ubuntu 18.10 with GCC and GDB installed. Before we look at memory, we need to disable address space layout randomization, which scrambles memory for security reasons. For our purposes, it just makes things unnecessarily hard, so we'll get rid of it. Use this command to see if you already have it disabled. If it shows 0, then you're good to go. But if it shows 1 or 2, then you'll need to run this to change it to 0. Now we're ready to write our C script. I conveniently have it already written and stored on desktop. Let's take a look at the content. It's fairly straightforward. I include a standard IO header file. The script only has one function, main. First line in the function declares a car variable of 23 bytes and assigns it a value. Remember this line, because when we're in the debugger later, we'll put a breakpoint right after it. The next line prints the variable back. Then the function returns 0 before exiting. Let's compile it using this command. GCC is the compiler program. -O ETT001 specifies the compiled program output location. ETT001.c specifies the source file, which is the file we just looked at. -F no stack protector disables the stack protector, which is another security measure modern compilers have, but it muddles up the stack, so we'll disable it here. Lastly, -G adds source file information to the compiled binary for debugging. We run it, and the compiled binary ETT001 is now on desktop. Now let's fire up the debugger to cut open the compiled binary. We're now dropped into the GDB command line interface. Issue break ETT001.c:5. It inserts a breakpoint at the beginning of line 5 in the source file. Now run the program. The program pauses at the beginning of line 5, which is after the declaration and assignment of the variable. This is a good point to look into memory. But before we do that, we'll need to know exactly where to find a function that is currently being executed. To do that, we run info registers to find a stack pointer for the current function. RSP is the CPU register on x86-64 platform that stores the stack pointer value. Copy this value, and now let's examine memory at that location. We issue the below command. X is the examine command. /24 indicates we wish to examine 24 bytes of memory. The second X specifies hexadecimal as the output format. B tells GDB to output results 1 byte at a time. And lastly, the memory address. This is the result. To read it, let's first orient ourselves. Notice the memory address grows from top to bottom and left to right, which happens to be consistent with the way most cultures read text. Convenient. After consulting the ASCII table, we find the values in the variable BTW, space, I, space, don't, space, use, space, arch, period, null termination. Notice that the variable is stored directly at the stack pointer. This makes sense because it's the argument build area, and this variable is about to be passed on to the next function, which is printf. As you can see, when stored in memory in car arrays in C, ASCII characters are stored sequentially without regard to Endianness. Thanks for watching. I'd like to give special thanks to USDA Prime Rib, who did not sponsor this video. It's loaded in saturated triglycerides, proven to reduce life expectancy. Sadly, I have not been able to say no to it during Christmas dinner. Maybe better luck next year. This is an Indian tribe production, all rights very much reserved.